Hello to all of you. My name is Joshua Woller. I'm together with my fellow students Zhenni and Leonie Terfurth, as well as our professor, Dr. Eva Wiese, from the Department of Cognitive Psychology and Ergonomics at the Berlin Institute of Technology. I would like to welcome you all to our presentation. We are presenting our paper, Mind the Machines, applying implicit measures of mind perception to social robotics. One of the success factors in the interaction between humans and robots is the formation of a useful mental model of the actions and states of the robot. In social contexts, this can be greatly influenced by mind perception. Mind perception is the attribution of inner mental states and capacities to any other entity, human or non-human, a living being, or even a technological apparatus. The degree to which we consider another entity to have a mind influences our pro-social behavior towards it, as well as the intentionality that we ascribe to it. For example, it affects how we interact with it and what actions in turn we expect from it. A widely used taxonomy to describe mind perception was developed by Gray and colleagues. It proposes two separate dimensions. One dimension, agency, refers to an agent's ability to act independently and to exert self-control. Another dimension, called experience, refers to an agent's ability to feel and to sense. Different agents vary systematically along those dimensions. Robots, for instance, are typically ascribed low experience and low to medium levels of agency, while adult humans, for instance, are normally rated highly along both dimensions. In social science, and especially in psychology, it is common to take a dual approach to such attitudes. One component is the explicit component, something that can be measured, for instance, by questionnaires. Another component would be an implicit component, and this can be measured indirectly, for instance, using reaction time-based measures. To gain a holistic understanding of attitudes, it is important to consider both in measurement. To our best knowledge, most research exploring mind perception towards robots has so far focused on the development and application of explicit measures. This means questionnaires and self-report scales. In general, we would expect implicit perception of the mind perception dimensions of agency and experience to be higher towards humans compared to robots. Further, we would expect this effect to be larger for the experience dimension than it is for the agency dimension. Regarding the relationship between measures of explicit and implicit mind perception, we did not have a strong previous hypothesis in mind. In our study, we modified an implicit association test, which is an established reaction time-based measure of implicit attitudes. Our modification aimed to assess mind perception towards robotic agents. The implicit association test method, initially developed by Greenwald et al., uses reaction times to measure participants' underlying implicit attitudes. This is reflected by the strength of association between different targets, for instance, flowers and spiders, and different attributes, for instance, good and bad. The rationale is that participants would be able to categorize stimuli faster, that they strongly associate with each other, so-called congruent trials, than stimuli for which they exhibit weaker associations, so-called incongruent trials. The result of the test, then, is a difference score between the reaction times in congruent compared to those in incongruent trials, the so-called D-score. In an IAT, there are two types of stimuli. Target stimuli, displaying members of the categories in which we are interested, as well as attribute stimuli, words for which we expect the targets to have differential associations. In our study, the target stimuli were selected images of humans and robots. Attribute stimuli were related to the dimensions of mind perceptions. Words indicating high and low agency for the one condition, and words indicating low or high experience for the other condition. The mind perception IAT therefore encompasses two separate IAT parts, one for the agency and one for the experience dimension of mind perception. Each IAT consists of 7 blocks of categorization tasks. The data collected in blocks 2 and 3, as well as 6 and 7, is used in the analysis for the computation of the D-score. The others constitute practice blocks during which the participants can familiarize themselves with the categorization task. Now let's look into the task in a bit more detail. So what you see here is a congruent trial. A stimulus shows up in the middle, and the participant then has to press a key to indicate the categorization. If it belongs either to the category human or to the category high agency, the button A needs to be pressed. If it belongs either to the category robot or to the category low agency, the button L needs to be pressed. Well, this is a congruent condition. And why is that so? Because we expect that the concepts of human and high agency and the concepts of robot and low agency are more closely associated with each other than it would be vice versa. Here, on the other hand, you see an incongruent trial, where for robot or high agency, the button A needs to be pressed, and L needs to be pressed if the stimulus is either the image of a human or word indicating low agency. After finishing both IATs, participants further answered an explicit mind perception scale for both agent types. Overall, the scale was short and constituted of 13 items that were rated on an 8-point Likert scale.
Total 51 participants took part in our study, which was hosted online on Amazon Mechanical Turk. And what you can see here are the results of our MP-IATs. While blue data is standing for agency data, the red is representing the experience results. And as you see, both do significantly differ from 0, so the D-score is negative. And looking back into the IAT methodology, this means that people took longer or were struggling harder when they had to categorize robot and high agency to the same key, while human and low agency, same for experience, was mapped to the same key. This slide here shows the results of our explicit questionnaire, and again, blue stands for agency and red for experience. And as you can see, humans were scored really high for both dimensions, and robots were scored lower for both dimensions. The discrepancy is significant for both, but here the difference in experience was higher because robots literally didn't get any ratings or very low ratings for experience. Because we already looked at explicit and implicit data now, we also correlated those two. So basically we correlated the data shown on the last slide and on this one. And we didn't find any significant correlations here. Conclusively, with that study, we have shown that mind perception towards robotic agents is already lower on a subconscious, fast-acting level, and that implicit and explicit measures of mind perception are not correlated, or at least not significantly correlated. And because we have shown that using this MP-IAT that we developed here, we kind of extended the toolbox that is now available to measure mind perception, and with that paved the way toward a more holistic understanding of human perception of robotic agents. The observation that mind perception has an implicit component is noteworthy on and on itself, and that's because this means that when we interact with robotic agents, there's a subconscious, fast-happening component of it. And so when we go into robotic design and only evaluate explicit measures, like it's done a lot now, we kind of have an analytical blind spot, the implicit part, which we just ignore, and this can lead to flawed behavior than in real-life scenarios. What is there to take home from our study is that the MP-IAT is eligible to measure mind perception towards robotic agents. And although there are some changes that can be made to improve the structure a little bit or to make it simpler, the framework this study laid out just bears a lot of potentials for future research. For example, an adaptation of this design can be used to look into robot-robot differences, like robots with eyes and robots without eyes, and then find out what the effect of the specific feature is on the implicit perception of mind. To allow for replication of this work, we uploaded the code and additional information on OSF, so it's really accessible for everyone. So thanks everyone for your time, and we're looking forward to see you on the conference and discuss our paper and your questions.